There is a certain quantity which we call energy that does not change for whatever changes that are occurring in nature. This is the statement of conservation of energy, which is one of the most basic laws in physics. Because it is a mathematical principle, it tells us about a certain number which is fixed and which we can count. When we count the number again after some time in which nature has played her tricks and games, that number does not change. That's strange because it feels contradictory to what we observe in our day-to-day tasks. We consume food, do different types of work, and at the end of the day, we feel tired. To be more precise, we lose energy continuously, but from the physics point of view, that lost energy should be present in another form. Now we are going to talk about some of the most basic forms of energy, which we are already familiar with, but we might not know what they exactly are. Till then, you can hit the like and subscribe button. Okay, so one of the most abundant forms of energy which we can see all around is the gravitational potential energy. It is some kind of potential energy which exists due to the force of gravitation, which is always there between masses. Here on Earth, when we throw something up, it comes back. We have to do work against gravity when we move up a staircase. A ball easily rolls down on a slope. What happens is that things store energy in the form of gravitational potential when they are kept at a certain height. Physics defines energy as the capacity to do work, and anything that is kept at a certain height with respect to ground has the capacity to do work, as it can be used to lift any object at a desired height. In doing so, it would lose its own height, rather its potential energy, and that is the cost it pays according to the law of conservation of energy. We can also find a formula, a mathematical expression that describes gravitational potential energy. We have seen already that gravitational potential energy only depends on height, mass of the object, and gravity. So, by simple arguments and first principle, we can find that its value is equals mgh. Another type of potential energies that are widely seen around us are elastic potential energy, electrostatic potential, magnetic potential, and a few more. But the basic mechanism behind their cause and the effect is the same as of gravitational potential energy. Whenever there is a potential energy, it must be due to the virtue of the position of the object when acted upon by a force of some kind, like the force of gravitation or the spring forces. Let us now move our attention to another important and abundant form of energy. You are right, the kinetic energy. Kinetic energy is the energy of motion. When something moves, it carries energy which depends only on the mass and velocity of that thing, and it has nothing to do with the gravitational field. In fact, kinetic energy can still be present in the absence of gravity. To understand this, consider a pendulum. If we pull the mass aside and release it, it swings back and forth. In its motion, it loses height in going from either end to the center. Where does the potential energy go? The gravitational energy must have gone into another form. As we can notice, it is only by the virtue of its motion that the bob is able to climb up again. So, we have the conversion of gravitational energy into some another form when it reaches the bottom, and we call this new form the kinetic energy. Again, by the first principle, we can find a formula for the value of kinetic energy, which is half mv square. Sounds very familiar, right? We can continue in this way to illustrate the existence of energy in another forms. There is heat energy which we use for cooking and boiling water. If we look at microscopic level, heat is nothing but atoms and molecules in motion, which is kinetic energy in subtle form. There is electrical energy which has to do with pushing and pulling of electric charges. There is radiant energy, the energy of light, which we know is a form of electrical energy because light can be represented as wigglings in the electromagnetic field. Next, we come to nuclear energy, the energy which is involved with the arrangement of protons and neutrons in the nucleus. And we have formulas for that, but we do not know the fundamental laws. Finally, we have modified form of kinetic energy. the relativistic kinetic energy, which is associated with the theory of relativity. In this form, kinetic energy is combined with something called mass energy. An object has energy due to its sheer existence. It has nothing to do with the motion or the position of the object, but it is the very presence of its mass. If an electron collides with a positron and they together disappear, radiation energy will be liberated in a definite amount that can be calculated knowing only the mass of electron and positron. This formula was first discovered by Albert Einstein and it is E equals mc square. It is clear from our discussion that energy exists in different forms and the law of conservation of energy is the key to link them. In quantum mechanics, it turns out that the conservation of energy is closely related to the absence of absolute time. In other words, we cannot differentiate a time interval now and a time interval little later. Time is homogeneous and so energy is conserved.